Last week we looked at the Bohr-Rutherford diagrams and how they relate to the periodic table, and we looked at our Lewis dot structures. Now what we're going to do this week is we're going to use them to predict ionic compounds and ion formation. Now, when we're looking at ion formation, one of the things we have to keep in mind is that atoms are most stable when their valence orbit or valence energy levels are full. And if the outermost orbit with electrons is not full, then that atom is not stable. And so what it will do is it can gain or lose electrons to obtain a full valence shell. And we call this our octet rule because, with the exception of our first orbit, the outermost orbits all hold 8. So let's take a look at what this means. So our first example is fluorine, which has an atomic number of 9. Which tells us it has 9 protons and 9 electrons. And from its mass number, we can get that we have 10 electrons. So we can draw our Bohr-Rutherford diagram, and we see that in its outermost orbit, it has 7 electrons. Okay? And now, to get this second energy level or second orbit full, it could gain 1 more electron. What it could also do is it could lose all 7 of these in the first orbit, would become valence because it'd be the outermost with electrons, and it's full with its 2. So therefore, this atom could gain 1 to fill its outermost, or it could lose 7. So when we look at this, it's easier to gain 1. And so this forms a stable ion. If we look at this in terms of our Lewis dot diagram, we have our fluorine with our 7 valence electrons around it, and we can show it gaining 1. Now, because it's now an ion, we put square brackets around it, and we put a -1 charge out here. Now, the reason it has a -1 charge is it has 1 more proton than electrons, because it's gained an electron, so therefore it has a -1 charge. When it started out, it had the same number of protons and electrons, so it was neutral. Then it gained 1 electron, and had a -1 charge. Let's take a look at another example, aluminum. Okay. We know from its atomic number it has 13 protons, 13 electrons. Its mass number allows us to determine 14 neutrons. Okay, we can draw our Bohr-Rutherford diagram, and we can see in our outermost energy level, or orbit, there are 3 electrons. So it has 3 valence electrons. So to fill this third orbit, it could gain 5 electrons. Or it could lose these 3 electrons, and the second orbit, which is full, would become valence. Okay, so it could gain 5 and fill the third energy level, or it could lose these 3 and the second energy level become valence and it's full. It's easier to lose 3 than to gain 5, so it's going to lose 3. And so as a result, our aluminum will have 3 electrons lost, and it will have its second energy level or orbit as valence. We can look at our Lewis dot diagram to demonstrate this. We have our 3 electrons around it. We're going to lose them. Now, because we've lost, in this case, rather than having dots around, we leave no dots around it. But it is a charged ion, so therefore, we're going to put square brackets around it. Okay. How about barium? Well, barium was not one that we looked at before in terms of its Bohr-Rutherford diagram, but we know that it's in group 2. So therefore it has 2 valence electrons. So we can draw its Lewis dot diagram, and now the question is, what will it do to obtain a stable ion? Well, it could lose these 2, or it could gain 6, because the outermost energy level holds up to 8. Okay? Well, it's easier to lose the 2 than it is to gain 6, so I'll lose the 2, and so therefore we write the symbol inside of square brackets. It has a 2 plus charge because it lost 2 protons. Or sorry, it lost 2 electrons. We put it in square brackets. We have no dots around it because it lost its electrons, and it has a 2 plus charge because it's lost the 2 electrons and now has 2 more protons than electrons. How about arsenic? Okay. We didn't do its Bohr-Rutherford diagram either, but we know that it's in group 15 or 5, so it has 5 valence electrons. So it could gain 3 or it could lose 5. Okay, it's easier to gain the 3, so therefore we can gain our 3, and because we gained, we show the 8 electrons around it, or it satisfies octet rule, and it now has 3 more electrons than protons, so therefore has a 3 minus charge. So, if we look at our periodic table, right, we talked about this last day, where we looked at our group, where we looked at our number of valence electrons, and we looked at our group number being equal to our number of valence electrons. So we can either gain 7 or lose 1. It's easy to lose 1, it's plus 1. Okay, group 2 will lose 2. Group 3 will lose 3. Group 4 can gain or lose 4. Group 5 will gain 3. Group 6 will gain 2. Group 7 will gain 1. Group 8 has full, so it doesn't gain any. So our ion is our particle that has a positive or negative charge, and an anion is one with a negative charge, and a cation is with a positive charge. Now, what we've seen is metal atoms will lose their electrons, non-metal atoms will gain. Okay? And metal atoms will lose to non-metal. So for example, if I have a sodium atom, which has its 1 valence electron, it's going to lose this 1 valence electron. Fluorine has 7 valence electrons. It's going to gain 1 to fill its valence energy level. So the electron from sodium will be lost. It'll form an Na plus because it now has 1 more proton and electron. That electron will be gained by fluorine, and so I have an F minus because now I have 1 more electron than protons. Okay, now we know opposite charges attract, so this positive charge will attract this negative charge, and they'll form what's called an ionic compound, which consists of a positively charged particle and a negatively charged particle held together by their electrostatic attractions. Okay, and we can show this with our Lewis dot diagrams. Loss of the electron from sodium to fluorine. So now I have a sodium ion, and I have a fluoride ion. The sodium ion and fluoride ion are going to be attracted to each other, and they're going to form. Okay, so let's take a look at another example, magnesium and sulfur. Magnesium has 2 valence electrons. Sulfur has 6, so magnesium is going to lose its 2 because it's in group 2, and sulfur will be able to gain both of them. Okay, so we can lose the 2 electrons to sulfur. So as a result, I form a magnesium atom with a plus 2 charge because now it has 2 more protons than electrons. It has no dots around it because it lost the electrons. Sulfur has gained the 2 electrons to fill its valence energy level, and so has a charge of 2 minus. Okay, they will attract each other. They'll attract each other and form an ionic compound with 1 magnesium ion with 1 sulfur ion. Okay, how about the case of aluminum and oxygen? Aluminum has 3 valence electrons, oxygen has 6. So aluminum is going to lose its valence electrons, oxygen is going to gain them. So this aluminum atom could lose 2 of its valence electrons to the oxygen, leaving still 1. But this oxygen atom can't gain any more. So as a result, what we'll do is we'll bring in another oxygen atom. We can gain it. But now it needs 1 more, so we can have another aluminum atom come in. And so what we see is 2 aluminum atoms will lose their 3 electrons, and those 3 electrons will be gained by 3 oxygen atoms. And we can write the formula for this compound as Al2, because I have 2 aluminums, O3, 3 oxygens. What about barium and nitrogen? Okay. Well, if we go back to what we knew before, what we can do is we can use our knowledge of their group and what charge they'll form as an ion to shortcut the process. And we don't have to draw our Lewis dot diagrams to show the transfer of electrons. So what I can do is I can write my symbol for my elements. Then what I'm going to do is I'm going to write the charge that they would be based on the group. Well, we know barium's in group 2, and elements in group 2 are going to have a plus 2 charge. Nitrogen's in group 5. 5, or 15, it's going to gain 3 electrons. So it's going to have a -3 charge. Now what I'm going to do is I'm going to crisscross the charges. And what I'm going to take the number that's in a superscript of one element and make it a subscript on the other. So this 3 will come down to here. I'm not going to bring the charge, I'm just going to bring the number. And so the 2 from the barium comes down here. I don't bring the plus. The 3 from the nitrogen is going to come down there. I don't bring the minus. Okay? And I'm just going to rewrite it. Ba3N2. So this Ba3N2 would be the combination. So 3 barium ions would combine with 2 nitrogen ions. How about calcium and carbon? I'm going to write my symbol. Then I'm going to write my charge. Calcium's in group 2, so it's going to lose 2. Carbon's in group 4 or 14, so it's going to gain 4 because it's at the top of the group. Okay, then I'm going to crisscross. I'm going to bring the numbers down, but leave the charges. So the 2 is going to come down. I don't bring the charge, just the number. The 4 is going to come down, bring the number, not the charge. I'm going to rewrite it. And in this case, I can reduce because these are both factors of 2. And so I get Ca2C. So 2 calcium ions will combine with 1 carbon ion. Well, what if we have our formula and we want to name it? Because in chemistry we have names for our compounds. Well, to name it, what we're going to do is we're going to write the metal name first, and then we're going to write the non-metal name second. But we're going to change the ending of the non-metal to IDE. So instead of oxygen, we look at our list over here. I'm going to change the ending to IDE, so it's oxide. And so Al2O3 is called aluminum oxide. What about our barium with our nitrogen? Our 3 barium ions with our 2 nitrogen ions. Again, we're going to write the metal name first, then we're going to write the non-metal name, and we're going to change the ending to IDE. So this is called barium nitride. So now what you'll do is you practice a sheet and apply this. Remember, when you're naming, it's metal name first, non-metal name second with the IDE ending. Here's our list of our endings. And when you're doing the formulas, you're going to crisscross. And so the number will come down, the charge, you don't bring the charge, and reduce.